Hey, ACT Prep, welcome to day 28. You should have your green sheet of paper here. So I want you to take a moment. We're going to pause the video so that you can work on the bell ringer. Take about 5 to 10 minutes. And when you're finished, then unpause the video and we will check our answers. Okay, let's check the answers for this bell ringer. The bell ringer is on vectors, adding and subtracting vectors. You had this in geometry as well as a previous lesson. So when we're doing vectors, you simply want to add the two x's, add the two y's. When we're subtracting, you're going to do 6 minus a minus 3. That gives us the plus 9. And then -1 minus 4. Here, we are just multiplying the vector by a scalar or a constant. So you just multiply each one of these by a 4. This goes back to finding the modulus, which is pretty much like a right triangle. You're finding the hypotenuse. So you create a right triangle, then the vector is the hypotenuse. So the formula is the square root of a squared plus b squared, or x squared plus y squared. Here's your x, here's your y. So -1 squared is 1, 3 squared is 9. That gives us the square root of 10. Can't simplify that anymore. You leave it the square root of 10. Find the distance for this complex number. It's complex because we have a real number and an imaginary. Remember, there is a coefficient of 1 in front of the I. This is where it's the square root of a squared plus b squared, which is the coefficient in front of I. So 2 squared plus -1 squared is going to give us square root of 5. And that's the length of that modulus. Okay, we're starting into our functions section. We're out of algebra, starting into functions, which is algebra. We're going to talk about arithmetic sequences and geometric sequences. You did have this in Algebra 1. I know, I taught it. So this is a review. We do arithmetic and geometric sequences because that's when we recognize a pattern. And if we can recognize a pattern with anything in math, we can write a formula. And if we can write a formula, it makes it simple for us. You also can program it into a computer and do really complex math problems. ACT questions are going to be straightforward, like, what is the nth term in the sequence? Here you've got this one. What is the next term in this arithmetic sequence? You need to know that arithmetic means you're adding or subtracting a number. Geometric is you're multiplying or dividing. So you can look here and go, oh, it looks like they're doing -3, -3, -3. That's the pattern. So what is -4 minus 3? Gives you -7. Yeah. Now, here's another example of finding a term. You might not be given the last one. You might be given a middle one. So what you need to do is take these terms that you do know that fall in sequential order and figure out what they're doing. So here I look at, okay, we could be adding a number, or it's kind of obvious we're not adding the same number here. So I might use my calculator and go, okay, what is 54 divided by 18? That's 3. They multiplied by 3. Now let's check. What is 54 times 3? That's going to give me 162. So we're going to multiply by 3. That's the one that works. Okay. So what is 2 multiplied by 3? 6. Our second term is 6. And then you can double check it, because if we're multiplying by 3, 6 times 3 should equal 18. It does. I'm good. Put a big star by this one. Now you might have more challenging problems. These are pretty straightforward and easy. The more challenging ones could be finding terms further along in the sequence. This is when you need the formula. These short ones here, you really don't need to memorize the formula. And this is going to be a hint for your exit ticket. You have to know the relationships in the sequences, and that will help you solve these types of equations. What relationships are we talking about? Is it arithmetic? Is it geometric? Are we adding? Are we multiplying or dividing? Or are we subtracting? You have to know which one of the relationships is, arithmetic or geometric, because you know which formula to use. Very, very important. Arithmetic sequences, you have each term is equal to the previous term plus a common difference. So here we were given this sequence earlier. We know it's subtract 3, but if we plugged it into the formula, we started with a 5, that's A1, that's our first term. The common difference is we're subtracting 3, and that's going to give us the second term. Here is the general rule for arithmetic sequences. If you want to find the number in whatever position, the 10th number, the 101st, the 75th, that would be in. You're going to take the first term in the sequence, okay, and you're just going to add it to the common difference times whatever this n is. So if we're doing the 75th term, we're going to do this one. This is 75. You've probably also seen it, and in Algebra 1, we actually did the first term plus, this is probably the formula you remember from algebra, n minus 1. This is the one that I use, because here I take 5 as the first term, this is the 75th term, so I would multiply -3 times 74. Now, let's talk about geometric sequences. Geometric sequences are where we are multiplying or dividing by this same number. That's what makes it geometric. A is going to be the very first term in the sequence. N is going to be, is it the first term, second term, 101st term, or you want the 2000th term? R is the common factor. When we're adding and subtracting, we call it the common difference. When we are multiplying or dividing, it's a common factor. So it goes to R instead of D. Here we're given this multiplication sequence from earlier. We already identified we're multiplying by 3. The first term is 2. Okay, the common factor is we're multiplying by 3. So if we set this up in the equation, okay, you can see here, if we want to know the second term, then it's going to be the first term. N is that 2 to the 2 minus 1. Okay, whatever this number here, we want the second term, so that N is a 2. So 3 to the first power is 3. This is going to be 2 times 3. It's 6. And again, you need to know these formulas for when they're asking for like the 15th term in the sequence, but for this problem right here, you can probably do it by hand. Let's look at our example. What is the 10th term? And this is where the formula is going to help you be faster. So take a moment, pause, take about 5-10 minutes, and solve this example, and then unpause, and we will go over the answer. Okay, so let's look at this one. If I know this is first term, second term, third, fourth, fifth, the numbers seem to be getting greater. There's no way it can be 50. There's no way. Yeah. I can almost look at it and already identify the pattern that we're multiplying by 2. So I know it's not this one, and I know it's not this one. Yeah, because, 80 times 2 is 160. It's got to be greater than that. So it's either 1280 or 2560. Now, you can take the time to go, okay, 6th term is 160. 7th term, multiply by 2, 8, 9, 10. Hopefully you have a calculator, or you can do the formula, which is going to be, okay, if we want the term in the 10th position, it's going to be equal to the first term, 5, multiplied by our ratio, which is times 2. We're multiplying by 2 to the n minus 1 power. N is 10, minus 1 makes it 9. So you're going to do 2 caret 9 on your calculator. Get that number and multiply by 5. It's really simple and fast. There you go. You see the formula, what I just put up, and you get 2,560. Again, could you do this by hand for the 10th term? Yes, but if they were to ask you for the 100th term, you'd waste too much time. You need to know the formula. All right, now we've got ACT questions. So I want you to, how many have we got? 5, yeah, don't look at those. Set 5 minutes on your watch, phone, timing device, and pause and get back with me on how to solve these. All right, great. Let's go over the answers. What are the next 2 terms in the sequence? Well, the numerators are not changing. It's just the denominators. And it looks like we're multiplying by 2. Again, what's 64 times 2? I know that's 128. Don't need these. And then 128 times 2, it's 256. That's pretty obvious. 100 times 2 is going to be 200. It can't be 160. Here's the one where you need the formula. What is the 100th term in this sequence? Because if you wrote it all out, yeah, no. So if we look at this, the 100th term, okay, we look like we are adding 2. That makes it an arithmetic sequence. And that's important to know because if it's arithmetic, then I know which formula to use. I have to identify that. So I know the 100th term is going to be the first term, which is negative 45, plus our difference, our common difference, which is 2, to the n minus 1. And n is 100, so that's going to make n minus 1 be 99. And we do the math. Take your calculator, 2 times 99 plus negative 45. That's going to give you 153. Again, this is an example where the formula is going to save you time. Next one, they actually tell you geometric sequence, and they want the common ratio. So they want to know what you're doing. We know the first term is a 5, second, third, fourth, fifth, sixth one is 160. We can't do this without the formula. There's no way. So let's do the formula. We've got the 6th term, a to the 6 is equal to whatever the first term is. We know that's a 5. I'm going to write it down. We know that's a 5 times whatever the common ratio is. That's an r to the n minus 1. So let's fill that in. First term here, our 6th term is 160 equals, first term is 5, and it's going to be times r to the 5th power because it's n minus 1. Divide both sides by 5, and you get, what is that? 5 goes into 160, 32 times equals r to the 5th. Take the cubed or 5th root of 32, and that's going to give you 2. So there's your common ratio. The last one here, we've got the 4th term of the geometric sequence is 7, and the 7th term is 1. What is the first term? Yeah, this one's a little trickier, isn't it? Mm-hmm. Yeah. What I end up doing here to find the first term, I do not have, because the formula calls for the first term, and I have the 4th term and I have the 7th term. So what I end up doing is I make this the first term. And if this is the first, then we've got from 4, you go 5, 6, 7. That will make this the third term. So I find out what my ratio is using this. So if the third term is 1, that's a to the third here, then it's going to be my first term, 1, times whatever the ratio is to the n minus 1, 3 minus 1, which is 2. Divide by 1, I end up getting that my ratio is oh, sorry, this should be a 3. Yep, I messed up. That should be a 3. So I need to take the square root of 3. So my common ratio is I'm multiplying by the square root of 3. Then I can go back and do the calculation where I've got my first term is the unknown. My common ratio is the square root of 3. I solve and I get 729. And the last one here we've got an arithmetic sequence. What is the 15th term? It looks like we are adding 5. So take the first term in the sequence. We want the 15th. So that is the first term, negative 12, plus whatever our common difference is, 5 times n minus 1, which is 14. 15 minus 1 is 14. Take your calculator. 5 times 14 is going to give you 70. Minus 12 gives us 58. Hopefully everybody got everything right on that. Yes, and we're improving. So now you have your exit ticket. Okay, and your exit ticket specifically says, and I said this in the lesson, explain to a new math student why finding the relationship between the numbers in a sequence is important to finding other terms. And I did that. If you have to rewind, you have to know the relationship. There's 2 specific relationships when we're talking about patterns. We specifically talked about 2 relationships. And why is it important that you identify those relationships? If you give me the answer so you can solve, no. I need to know why it's important to solve, why you have to identify it. So have fun on the exit ticket. If you have questions, take a screenshot, send it to me, or ask me in class before you turn it in. And see you then.